In this lecture, we will look at a few examples of tidal stream or tidal current generators. There are many devices being developed. I've picked a few that have been subjected to considerable testing, mostly at the European Marine Energy Center, a facility that we encountered when discussing wave energy conversion devices. The ocean is a tough environment at the best of times, so these types of tests are extremely important in validating new designs. Due to the strong interest in developing the tidal energy potential of the Bay of Fundy, a new research center, the Fundy Ocean Research Center for Energy, or FORCE, has been established in Nova Scotia and currently has projects underway in the Minas Passage at the tip of the red arrow, which has very strong tidal current flows. So the Fundy Research Center essentially has underwater electrical infrastructure in place so that technology developers can set up and connect directly to the grid. And the center also provides environmental monitoring. So there's the Bay of Fundy is an important commercial fishery, and the studies currently underway include tracking both fish and lobsters to ensure that there's no impact of the tidal current generators that are being tested. So let's start off with CGen. CGen was developed in the UK by a company called Marine Current Turbines, which is now part of Siemens. The development of new technology is certainly a financially fraught process, so it's always encouraging to see an emerging developer being taken over by a company with the resources to see the development through. This technology started in 1999 with a 15 kilowatt prototype. The version shown, called Seaflow, was tested off UK in 2003, just 300 kilowatts. And a feature of this technology is that the blades can be rotated all the way around, so they're variable pitch blades, and they can essentially be rotated all around to deal with the reverse tidal flow. So they can capture power on both the flood and the ebb tide. So a full-size CGen has been installed in the Strangford Narrows in Northern Ireland starting in April 2008, and has recorded power outputs of 1.2 megawatts between 18 and 20 hours of the day. So that's a really strong tidal current flow. The unit was grid connected in 2008, so has the claim of being the first large-scale commercial tidal stream generator. So here are some illustrations of what it looks like in practice, the full-size unit. So it has two rotors. The picture on the left shows a view from above the water. You don't see anything except this large structure, and the picture on the right shows the unit raised for service. So that's a feature of this design, is the beam holding the two rotors can be raised above water for servicing. So just to give you an idea of the scope, it's always good to look at things in the context of a human. So here you can see the whole assembly with the two rotors. So here's the left rotor and the right rotor on its supporting structure awaiting installation. The rotors are 16 meters in diameter, and each of the rotors develops a 1 megawatt output peak for a total of 2 megawatts maximum output. So to come back to the Bay of Fundy again, the CGen technology is being demonstrated in the Bay of Fundy, and there's a unit currently scheduled for installation in 2015. You can find out more about that by following the link. So let's go to a slightly different technology. So this is a technology developed by a company called Open Hydro, which is based in Ireland and now acquired by again by a large company. It's from 2013. They have a website with lots of information, so you can check that out. I just show one image here which shows the unit sitting on the seabed, and you can see a turbine, essentially a ducted turbine supported in the structure. The opening at the center is to allow fish to pass, which is an interesting concept. You don't actually get much power out of the low radius blades. So Open Hydro has a number of projects underway. They were the first to test a prototype at the European Marine Energy Center. There is a plan again in the Bay of Fundy to install a 4 megawatt tidal array, so they would have the first tidal array in the Bay of Fundy. It consists of two 2 megawatt units, and more information is available by following the link. Also in France, they recently signed a deal with Electricité de France for 2 megawatt tidal turbines to be installed in Brittany, roughly in the same time frame. There's also a deal signed with a Channel Islands company to establish a joint venture to develop a very large tidal array, 300 megawatts. That'd be 150 turbines, but certainly no dates have been announced for any concrete activity in that joint venture. So there's a YouTube video which illustrates the technology here, so you can check that out on your own. And one final type. I don't have a picture for this one. It's a propeller type as well, so somewhat similar to at least the rotor anyway of the CGen. It's called DeepGen, and a 500 kilowatt system was tested in European Marine Energy Center starting in September 2010. And as of March 2012, it had achieved a total production over that, that time period of 200 megawatt hours in grid-connected operation. In 2013, a 1 megawatt unit was deployed on the same seabed test structure and developed its full rated power in July of that year. Subsequently, Alstom, the current owner of Tidal Generation, the developer, and Scottish Power signed a memorandum of understanding to develop a project with 4 tidal current generators, so 4 1 megawatt units. So once again, the operation of this device is illustrated in a nice YouTube video, so you can follow that link and see. Okay, so these are just 3 examples. Again, I picked these because they all 3 have seen significant amounts of testing, and testing is essential to develop these devices for what is really a brutal environment for machinery. So just a few words of summary. The tidal current generators have been tested or are being tested at the European Marine Energy Center in the Orkney Islands and at Force in the Bay of Fundy. So there have been some grid-connected test programs, but I would say that there's really been no commercial service yet, in the sense that the units are finally in place and intended to be in place for 20 years or so. Although some initial demonstration projects are in development for late 2015. And really important is that these tests have been arranged so that environmental impact studies are being carried out at the same time. And certainly initial findings in the Bay of Fundy, there appears to be a much reduced environmental impact compared to tidal barrages. Now, one aspect for that is, of course, that these tidal current generators are modular systems, and you can build the capacity slowly, but also that means that you may not see any environmental impact with 1 or 2 units. And so the next question is, as you build an array, what happens? Does that have any impact? So very interesting question, but certainly compared to tidal barrages, which by their mere construction cause huge environmental disruption, certainly the tidal current generators look to be much more reasonable. So, some questions for your own thought. Can you identify any regional or local sites that have potential for a tidal current generator or even a tidal array? multiple tidal current generators. Are there any environmental or practical issues that might be problematic for that installation?